All right, let's go over this 6.4 worksheet 1 on sum and difference of two cubes and factoring by grouping. So first one here is a sum of two cubes. So first step is we need to find a. So a is the cube root of that first term, so the cube root of x cubed, which is x. B is the cube root of 125, which is 5. And if you don't know that, I'm going to show you two ways to find that. So let's clear that. So I'll show you how I get it. So this website here is desmos.com/scientific. That'll bring you to a scientific calculator. So what you want to press is this button right here. And since we want the cubed root, we put a 3 up here. And then underneath the radical, we do 125. And that gets us an answer of 5. So that's first way. Second way, if you have your TI-84, and you hit the math button right here. The fourth option is the cube root. So you can press number 4 or you can scroll down. That brings you to this. Type in 125, enter, and answer is 5. So that's two ways to find that. So then we go back here. We figured out cube root of 125 is 5. So now we need to do our sum of two cubes. So we know that that's a plus b times a squared minus a times b plus b squared. So in this case, that's x plus 5, and then x squared minus 5 times x plus 5 squared, which is 25. So number 2, same idea. It's a sum of two cubes. So a is the cube root of a cubed, which is actually conveniently just a. B is the cube root of 64, which is just 4. And then we do the same thing. So we use this formula again. So a plus 4 times a squared minus 4 times a plus 4 squared, which is 16. All right. All right, so our next one here is a difference of two cubes. So we start the same way by finding a and b. So a is the cube root of x cubed, which is x. B is the cube root of 64, which again is 4. This time we use our difference of two cubes. So that is a minus b, and then a squared plus a times b plus b squared. All right, so then we do x minus 4 times x squared plus 4 times x plus 4 squared, which is 16. All right, next one, we've got a sum of two cubes again. So a is the cube root of u cubed, which is just u. B is the cube root of 8, which is 2. So that will be a plus b, which in this case is u plus 2 times u squared minus 2 times u plus 2 squared, which is 4. All right. Next, actually the last two of these are both difference of two cubes. So this one here, we've got a is cube root of x cubed, which is x. B is the cube root of 27, which is 3. So we do a minus b, so x minus 3 times x squared plus a times b, so 3 times x, plus 3 squared, which is 9. And then this one right here, now this one's a little different because the variable comes second, but that's okay. It's just still the first term, so a is the cube root of 125, which is 5, and b is the cube root of x cubed, which is 3. Now it does matter. You can't use x as a because the x doesn't come first, because as we know, order matters when it comes to subtraction. So the 125 is first, means the 5 has to be a. So this is going to be 5. Sorry, this should be an x. I don't know why I wrote a 3 there. So 5 minus x times 5 squared, which is 25, plus 5x plus x squared. Now, the only thing I want to change here, the 5 minus x is okay. I don't like that this quadratic has the x squared at the end, so I'm just going to rewrite it this way. I wouldn't mark you wrong if you left it the way it was, but this is just a personal preference of mine. I like it this way. So let's now move on to the next part of this worksheet, which was factoring by grouping. Let's change the color to spice things up a little bit. Make it purple. All right, so we follow our 3 steps for all the factoring by grouping problems. So step 1, group together the first 2 and the last 2. Then we factor out a GCF from both. So this first set of parentheses, we've got a 12 and a 9. I'm going to factor a 3 out with the coefficients. And then we have an a cubed and an a squared. Didn't mean to write that yet. So I would like to factor out an a squared. So then if we factored a 3 out of this 12, we're left with a 4. If we factored an a squared out of this a cubed, we're left with an a. And then right here, we factored a 3 out of this 9, so we're left with 3. And we factored out the a squared, so that's just 3 times 1. And then this one right here, I actually can't factor anything out of this. There's no GCF. The GCF is actually 1, so we're really just factoring out a 1. So I'm going to write that. So 1 times 4a minus 3. Now, the reason I want to write this 1 here is because when we take out our common factor here of 4a minus 3, our second one is actually going to be 3a squared plus 1. So if you don't write that the GCF is 1 right here, you might forget this one. So just be careful with that. It might help you to actually write the 1 in this case. Okay, so next one. We group together 2p cubed plus 5p squared plus 6p plus 15. Great. All right, so this first set of parentheses, we have a 2 and a 5, so we can't factor anything out besides a 1 there. Then we have a p cubed and a p squared, so I'll factor out a p squared. Then we're left with 2p plus 5. And then the second set of parentheses, we have 6 and 15. I can factor a 3 out of that, and we're left with 2p plus 5. So then we've got this. All right, so here we go. This first one, we group together 3n cubed minus 4n squared plus group together 9n minus 12. So the 3 and the 4, we can't factor anything out besides a 1 there. We have n cubed and n squared, so we'll factor out an n squared. So then we have 3n minus 4. Then the second set, for our coefficients, we have 9 and 12. So I can factor out a 3, and then we're left with 3n minus 4. All right, so then we have 3n minus 4 times n squared plus 3. All right, so number 4 here, we group together this, and then group 3n plus 1. All right, so this first set of parentheses, we have a 12 and a 4, so I can take a 4 out of both of those. I don't know why I keep doing that. I didn't mean to draw that yet. So we take out a 4. Then we have an n cubed and an n squared, which means I can factor out an n squared of both of those. So if we factored out a 4 from this 12, we're left with a 3. We factored out an n squared from this n cubed, so we're left with an n. And then we actually factored out 4n squared, so we're just left with a 1, because 4n squared times 1 is 4n squared. Now this second term here, we can't factor anything out. The GCF is a 1. So again, I want to write that so I don't forget about it. So then we have 3n plus 1 times 4n squared plus 1. Again, I want to factor out my GCF of 1 so I don't forget to put it right here. All right, so number 5, group together m cubed minus m squared, group together 2m minus 2, and then we factor out GCFs from both set of parentheses. So we have an m cubed and an m squared, which means I can factor out an m squared, and I'm left with m minus 1. Again, think about it like backwards distributing. If you were to distribute this m squared back into it, you want to make sure you get this again. So m squared times m is m cubed. M squared times 1 is m squared. So we're good. The second set of parentheses, I can factor out a 2 from the coefficients, and then I'm left with m minus 1. So then we take our like factor out, m minus 1 times m squared plus 2. Number 6, we group together the first two terms. Then we group together the last two terms. From this first set of parentheses, I can factor out a 5 from the coefficients. Then we have n cubed and n squared, so I can take out an n squared. And I'm left with n minus 2. And then from the second set, I can factor out a 3 from the coefficients because we have 3 and 6. And I'm left with n minus 2. So we have a common factor of n minus 2, then times 5n squared plus 3. And that is it for that worksheet.